Well, thank you all for being here. We appreciate your time. We are the Commission on the Future of Humanity. And as some of you are aware, we expect about 35 to 36 hours, your world will be sucked into an anomaly, a black hole-like anomaly. We expect that, first of all, energy will be sucked in, your corpses will freeze, and then be sucked into the black hole and crushed for eternity. Now, that's the future for most of you. However, 15 of you have been selected for your intellectual and genetic superiority to colonize Mars.
This colony, as you can see, it's going to be a fantastic place to live. It's got gardens, it's got great exercise machines. You're really going to enjoy it there. However, as you also might know, Mars doesn't have the most friendly environment for humans. And so our colony is going to need to have a controllable oxygen supply. And that's because as humans, we typically demand a little less oxygen at night than we do during the day. If we start exercising, we need more oxygen. And we'll also need a controllable oxygen supply if somebody say comes or ends up leaving the colony for some reason or another. So our key problem was creating a controllable oxygen supply.
Now we, the Commission on the Future of Humanity, have scoured the world and recruited the world's best world-renowned experts really on electrolysis. That's the chemical reaction that's going to drive the production of oxygen which you will need to survive in this colony. And the way it's done is NASA has, through several reports, identified that there's underground reserves of water and ice on Mars, which we will mine and then put through electrolysis reaction to produce oxygen and hydrogen. And the electricity that will be used in this reaction comes from three main sources. The first, which will handle the base load, will be a series of nuclear reactors. Now this is submarine-grade nuclear reactors that are tip-top shape. They're going to handle the base load demand. But for those swings in the transition between wake and sleep cycles, there's going to be a solar panel to help with that swing demand. And then any surplus power is going to be stored in a battery. And the charging and discharge of that battery will help also in the swing cycles as people wake and go to sleep. And that is controlled by a integrated control loop system.
Now, we wanted to be absolutely certain that this control loop system would work, and so we've created a simulation that you can see on the screen. In the top left-hand corner, you can see modeled your oxygen demand. There's a base load of 14.7 moles per day, and then obviously a pulse generator for daily cycles, and a disturbance variable that accounts for things like if you exercise, if you start breathing heavily for any reason. Now that oxygen supply is then multiplied by 15, the number of you who will be surviving, and it is then converted into a megajoule number, so basically the amount of energy that's required to produce the oxygen that you will be consuming. Towards the bottom, you can see three boxes that represent our three generators, the nuclear, the battery, and the solar generator. Those two values of power are compared, and we get a demand difference. That's the difference between the energy demanded by your oxygen consumption and the energy supplied. That value is then fed into a PID, two PIDs at the bottom of the screen that work in tandem with one another. One controls the nuclear reactor and has it ramp up or ramp down depending on your oxygen demand. And then the second PID above the nuclear reactor PID is our battery, which integrates the difference between supply and demand, stores that energy, and then discharges when there's a quick difference that needs to be made up between supply and demand. Our results can be seen here. First of all, the power demand, or the oxygen that you're consuming, is on the left, followed by power supply, and the difference between the two is shown on the bottom. Now, we've studied you and found that you can survive about 4% plus or minus in your oxygen demand. And so that corresponds to about 20 megajoules difference that can be sustained. Otherwise, you will die of hypoxia or oxygen poisoning. And as can be seen from our results on the bottom of the screen, our differences are much less than 20 megajoules. In other words, the control system works. It's going to be able to supply you with the oxygen you need.
So for those 15 of you who are going to be on this colony, congratulations. Again, you're going to love it there, and be confident knowing you'll have as much oxygen as you need. For the rest of us, we're sorry. Enjoy the last 35 hours and have a Merry Christmas.